These are the notes for parallel and perpendicular lines. We are in the first lesson of Unit 4. Our essential question is, how can you tell if two linear equations are parallel or perpendicular? Now, you might have heard these words in middle school where you talked about parallel and perpendicular lines, but what makes two lines parallel and what makes two lines perpendicular is really what we're going to go into today. We're going to justify whether two lines are parallel or perpendicular, and then we're going to actually write equations of parallel and perpendicular lines. So let's go ahead and go through some vocabulary. Parallel lines. Well, parallel lines are going to be two lines that never intersect. Technically, you could have more than two, so I'm going to just put lines. Lines that never intersect, or in other words, they'll never cross each other. So they'll never intersect or cross. Now, the way that I learn parallel lines is the fact that two lines never cross, and it's because there's two L's in parallel. So there are two L's in parallel. These two right here remind me of parallel lines. They're never going to cross each other, those two L's. The symbol for parallel lines is actually, it looks like this. It's like a diagonal, and it's two diagonal lines next to each other. So that's the symbol for parallel. So those are two lines that never cross. Now, the way you can have parallel lines is the only way for two lines to be parallel and to never cross each other is if they have the same slopes. So for example, go ahead and go to Desmos and kind of talk about two different equations here. So let's say I have y equals 2x plus 3. Now again, this is in slope-intercept form. Your slope here is 2 over 1, and your y-intercept is positive 3. So positive 3 is our y-intercept here. And then we'll have y equals 2x minus 5, for example. Now these two equations both have a slope of 2, but their y-intercepts are different. And what do you notice about the green and the blue line? They'll never cross each other. If I zoom up all the way over here and zoom in, they'll never cross each other. So if they have the same slope, they will never cross. Okay, now perpendicular lines. So what is a perpendicular line? Now people will say, oh, it's two lines that cross. That's not necessarily true. Just because two lines cross doesn't mean that it's perpendicular. So it has to be a special relationship between those lines. So perpendicular lines are lines that intersect or cross at a 90-degree angle. Okay, so those are lines that cross at a 90-degree angle. Now you're like, oh, do I have to get a protractor and measure out the angles? No, you're not going to do that. But if we're talking about the definition of a perpendicular line, that's what it is. Now the symbol for perpendicular is actually, it's like an upside down T. It looks like this. So it's a perpendicular symbol, and then there's the parallel symbol. Let me go ahead and give you an example of what is perpendicular, like kind of like a picture and what's not. So just a small example. So perpendicular lines, it's two lines that cross, but they must form a right angle. So if I were to measure the angle, it should be 90 degrees in there. An example of not perpendicular will be like these two lines. Oops. They cross, that's so not straight. Okay. There we go. Those two lines cross each other, but they're not perpendicular because they don't cross at a 90-degree angle. Now again, we're not going to be measuring angles here. You guys are going to be creating equations of lines, and you don't have to worry about the degrees, but I'm kind of just showing you like a graph, like a picture. That's what they would look like. Perpendicular would cross at 90 degrees, whereas not perpendicular would just cross in general, but it doesn't mean they're perpendicular. Now what makes two lines perpendicular? Now with parallel lines, the way that they don't cross or intersect is that they have the same slope. With a perpendicular line, you have opposite reciprocal slopes. And you're like, what does that even mean? So let's talk about what opposite means. When I'm talking about the word opposite means your sign is going to change. So if the original slope was positive, when you're creating your new equation, it's now going to be negative. If the original slope was negative, it's now going to be positive. So that's what opposite means, okay? Opposite means flip the sign. Change the sign from whatever it was previously. Now here, if it's parallel, if the slope was 2, it's going to stay 2. Like, you want parallel, you want the same exact thing. With perpendicular, not so much. Now here's the reciprocal part. Reciprocal means you're going to flip your fraction. So if you have the slope of, let's say, 2/3, you now have the fraction 3 over 2. So opposite means you change the sign, and reciprocal means you flip the fraction. You have to do both. The problem with this is that people tend to only change the sign and they forget to flip the fraction. So be very, very careful with that. All right, so we're going to do some examples so that we get some practice with opposite reciprocal before we actually jump into anything. So we're going to do some examples. 1/2. If this is my original slope and I wanted to make a parallel line, then I would keep it the same. Parallel means same slope. So if my original slope is 1/2, the new slope is also going to be 1/2. But if I want to make it perpendicular, I have to flip the sign and change the fraction. So my new slope would be, well, the first thing I do is, well, right now 1/2 is positive, so now it's going to be negative, and then I flip the fraction and it becomes -2/1, which simplifies to -2. Another example. Let me go ahead and highlight. So this is my old, whoa, that's a very big highlighter. This would be my old slope, and this would be my new slope. Okay, if my original slope was -3/4, then if I want to make a perpendicular slope, remember perpendicular is opposite reciprocal, perpendicular, then I would change the sign. So because it was negative, it's now going to be +4/3. And no, you don't have to write the plus sign there, but know that if there isn't a negative, then it's obviously positive. And then the last example, let's see if we can get this one. -5. Okay, so -3/4 to 4/3. -5. Well, -5, that's our original slope. If we want to parallel, keep it the same. Perpendicular, you must do opposite reciprocal. So because it's -5, it's now going to be positive. It's going to be positive whatever number that is. Well, how do I write 5 as a fraction? Wasn't 5/1? So if it's 5/1, now it's going to be +1/5. So -5 becomes +1/5. Okay, negative becomes the positive. Negative, now it's a positive. And then your fraction flips. So it's 5/1, now it's going to be 1/5. So it's going to take some getting used to do that, but you only do that for perpendicular. Parallel is really easy because you just keep it the exact same. All right, so down here we're going to determine if these lines are parallel, perpendicular, or neither. So we're going to start off with number 1. Now, the easiest form for you to identify the slope in is slope-intercept form. So y = mx + b. Okay? You want to look at the slope. The slope is going to tell you whether two lines are either parallel, perpendicular, or neither. You want it in slope-intercept form, which means you want y to be by itself. If y is not by itself, you do not know the slope. If y is not by itself, you do not know the slope. All right, starting with number 1. Y = 3x + 4 and y = 3x - 7. Now, first question is the first equation, I'm going to go ahead and kind of star them, is the first equation in slope-intercept form? Yeah, the slope here would be 3. Okay, +3, that's fine, that's perfect. Okay, do we know the slope of the second equation? Yes, we do. And why do we know that? Because it's already in slope-intercept form. It's in y = mx + b. Well, what's your slope here then? Your slope here is 3. So your slopes are the same. So are these lines parallel, perpendicular, or neither? These lines are going to be parallel to each other. They're the same slope. Okay, remember, two lines to be parallel have to have the exact same slope. So if one's +3, the other one also has to be +3. And I can prove this by graphing it into Desmos, right? If I have y = 3x + 4, and then y = 3x - 7, oh, let me go back home. See, these two lines are never going to intersect each other. So they are indeed parallel. They have the same slope. Now, number 2, 7x + 3y = 9, and y = 7/3 x + 6. Now, the first equation, I'm going to go ahead and star in red. Is this equation in slope-intercept form? No. So do you know the slope of this equation yet? No. The most common mistake is people think the slope is 7 because it's next to the x. But this is not in slope-intercept form. This is in standard form, which means we're going to have to convert this so that it is in slope-intercept form. So now we're using our knowledge from Unit 3 to convert this to slope-intercept form. Remember, slope-intercept form is y = mx + b, so we're going to try to get the y by itself here. So our very first step we're going to do is subtract 7x from both sides of our equation. 7x - 7x is 0. We are left with 3y equals 9 and 7x are not like terms, so you write them next to each other, 9 - 7x. And then the very last step here, we're going to divide everything by 3. Because you want to get that y by itself. 3 divided by 3 becomes 1, so 1y equals 9 divided by 3 is 3. -7/3 simplifies to -7/3. And then don't forget your x. You want to leave that x there because that x did not go away. Is this in slope-intercept form now? It is. It's in y = mx + b. So what is your slope here? Is it the 3 or is it the -7/3? Well, remember, in slope-intercept form, your slope is attached to the x. So your slope here is -7/3. So the slope of our very first equation is negative 7/3. Okay? Let's talk about the second equation here. Y equals 7/3 x plus 6. Now, what's the slope of this equation? Do we know it already? The answer is yes. It's already in y equals mx plus b. It's in slope-intercept form, so I don't have to do any work. The slope here is 7/3. Okay, so let's talk about if it's parallel, perpendicular, or neither. Because once you identify the slopes, then you can determine whether they're parallel, perpendicular, or neither, just like in number 1. Well, the slope of the first equation was negative 7/3, and the slope of the second one was positive 7/3. Okay, are they parallel? The answer is no, they are not parallel because they have to be exactly the same. So they either both have to be negative 7/3 or they both have to be positive 7/3. You can't have different signs. So these are not parallel. They have to be exactly the same. Are they perpendicular? Well, perpendicular means they have to have opposite reciprocal, which means they have to be opposite signs. So one has to be positive, one has to be negative, and reciprocal means they both have to be opposite fractions. So if one is 7/3, the other one has to be 3/7. So is this perpendicular? Nope. So this is actually neither. It's neither parallel or perpendicular. Okay. If you wanted a parallel, if you wanted a perpendicular line, then the new slope would have to be negative or positive 3/7. These two would be perpendicular because they have to be opposite signs, but they also have to be flipped fractions. So the way it is right now, they're not perpendicular to each other. They're not even parallel. They're neither. They're just two lines that cross, but they're not. There's no special relationship in between them. All right, number 3, y equals 2/3 x plus 1, and then 3x plus 2y equals 6. First step is, if we want to see if they're parallel, perpendicular, or neither, we have to check the slopes. In order to see the slopes, you want it in slope-intercept form. So starting with the first equation, is this in slope-intercept form? Answer is yes, it is in y equals mx plus b. And what is your slope here? Well, your slope here is going to be 2/3. Remember that in slope-intercept form, it is attached to your x. All right, so the slope for the first equation is 2/3, so that's easy. We don't have to do any work for that one. What about the second equation in green here? Is this in slope-intercept form? Nope, it is in standard form, which means we're going to have to get y by itself so that you can see that the slope is. So first step is I'm going to, how did I do this one? The other one, let me check. I don't want to do more work than I need to. Okay, the first thing we're going to do is we're going to subtract 3x from both sides. So we have 2y left over equals 6 minus 3x. And the next step here is you want to divide everything by 2. So divide by 2, divide by 2, divide by 2. 2 divided by 2 is 1, so we have 1y equals 6 divided by 2 is 3. And then negative 3 divided by positive 2 is just negative 3/2x. So then what's your slope here? And actually, I think I'm going to change this color to like purple. So what's your slope here? Well, the y is by itself. It is in slope-intercept form, but what's the slope? Is it the 3 or the negative 3/2? Your slope here is negative 3/2. Remember, your slope is attached to your x in slope-intercept form. So that means that the slope of the second line here is negative 3/2. So the first question is, are these parallel? Answer is no, they're not the same slope, they're not the same number, they're not parallel to each other. The second question becomes, is this perpendicular? Well, let's see if it is perpendicular. Perpendicular means they have opposite signs, so one's positive, one negative. That checks out. And then reciprocal means they have to be opposite fractions of each other. So this one's 2/3 and this one's 3/2. Those are opposite and reciprocal, which means these are perpendicular. Okay. So again, let me go through the process of that. If I have 2/3, I want to make an opposite reciprocal slope, that would be negative and then flip the sign 3/2, which is exactly what we have here, which means these lines are perpendicular to each other. Opposite signs and reciprocal, so they have to be flipped fractions also. That's why number 2 didn't work out. It was opposite signs, but they weren't reciprocals of each other. And then lastly, number 4, starting with the first equation, y equals 3 minus 6x. Well, is this in slope-intercept form? It is. It is in y equals mx plus b form. Your y is completely by itself. Well, what's the slope here then? Well, your slope here is going to be negative 6. Remember, your number that is the slope is attached to your x. It's not the 3. Okay, let's go to the second equation. Is this one in slope-intercept form? Is this in y equals mx plus b? Answer is yes. It is in slope-intercept form. And so your slope here is positive 6. All right, well, let's look. Are these parallel to each other? The answer is no. If they want to be parallel, they have to be exactly the same. Are they perpendicular? Perpendicular means opposite signs, but they also have to be flipped fractions of each other. They do have opposite signs, but they're not flipped fractions. So they're not perpendicular either, they're neither. And let me explain why they are neither. Okay, if I want a -6 and to be a opposite or to be perpendicular to something else, the slope of that new equation would have to be, well, if it's -6, the new slope has to be positive, and then you have to flip your fraction. Well, right now it's 6/1, so your new slope would have to be positive 1/6. And that is not what we have down here. We just have +6. So here's another case of, here we make a common mistake. Number 4 is a common mistake made on quizzes and tests because you see that they're opposite signs, that one's positive and one's negative, so you think they're perpendicular. But they're not because they're not reciprocals. They have to be flip fractions of each other. All right, moving on to the next section, we're going to write equations of parallel and perpendicular lines. Now, to write an equation of a parallel or a perpendicular line, it causes us to think a little bit more about what we need to do. So I'll kind of go ahead and show you how this is set up. So for the first problem, we're going to do 2 different lines. They're going to give us an equation, and then they're going to give us a point, and it's going to be the same equation and point for both sides. So if you'll notice, write an equation that goes through -2, 3, and is parallel to y equals 3 minus x in slope-intercept form. Over here, write an equation that goes through -2, 3, and is perpendicular to y equals 3 minus x in slope-intercept form. So they're almost identical, except for one we're going to do a parallel line, and the other one we're going to do a perpendicular line, but we're going to use the exact same point and same equation. So let me go ahead and kind of show you what we're doing. So we're going to do parallel first. Now, with these types of problems, it is super important that you are reading and making sure you are aware of what kind of line you are trying to create. So here we wanted to go through the point -2, 3, and then we want it to be parallel. Okay, parallel line. So do parallel lines have the same slope or opposite reciprocal slopes? They have the same slope. Okay, so we have a point, and then they're giving us an equation, y equals 3 minus x, and we want to write our final answer in slope-intercept form. That is going to be, I'm trying to figure out what color to use. I'll use yellow. In slope-intercept form, so y equals mx plus b. Okay, now obviously if they don't give us enough information and all we have is a point and a slope, we're going to start in point-slope form, which is why we learned Unit 3 before we learned Unit 4. So we wanted to go through the point -2, 3 and parallel to y equals 3 minus x. Let me go ahead and graph this for you to show you what exactly we're doing here. So they're giving us a point. Oh my gosh, will it load? They're giving us a point -2, 3. Okay, and then they're giving us the equation y equals 3 minus x. Now obviously that red point doesn't go through that blue line, and there's a reason for that, because we're trying to create an equation that goes through that red point. So the blue equation's already there. Now we're trying to make a new equation that goes through the red point and is parallel to that blue line. So let's go ahead and do that. Okay, well I have a point, and in order to create an equation of line, I need a slope. So let's go ahead and identify the slope of this line. Now remember, you only know the slope if it's in slope-intercept form. We want it in y equals mx plus b. Is this in slope-intercept form? Yes, it is. So your slope here is going to be, you got to figure that out, right? Your slope is always attached to x in slope-intercept form. So where's your m here? Your m's going to be right here next to your x, which is going to be -1. So your slope is -1. Now the question is, if we want to make a parallel line, should I use this exact same slope? The answer is yes. So we want to keep the slope as -1. We want to keep it as -1 because we want a parallel line. Okay? Remember, parallel lines have to have the same slope. So the regular slope, the red line, or the blue line, right, is the blue line in our thing. That has a slope of -1. We want to keep the new equation to have a slope of -1 as well, but we want it to go through this point. So now I have a slope, and I have a point. So if I have a slope and a point, I'm going to use point-slope form. So we're going to start in point-slope form. Y minus y1 equals m times x minus x1. All right, so go ahead, we'll plug in our point. So y minus 3 equals our slope, which is going to stay -1. We want to keep it as -1. And then x plus 2. Remember, opposite signs in point-slope form. All right, now, is this our final equation? No, because they want us in slope. We want it in slope-intercept form. We want it in y equals mx plus b, which means you're going to have to distribute here and do some more work. So the next step here is to kind of distribute this out. So y minus 3 stays the same. -1 times x is just -x, or -1x if you want to write the 1 there. And then -1 times +2 is -2. And then our next step here is we want to get y by itself to get it in slope-intercept form. So we want to add 3 to both sides. So this would be y equals negative x, negative 2 plus 3 is going to be positive 1. Is this in slope-intercept form? Yes, it is. Let's talk about what we just did here. Okay, this is in slope-intercept form. Now, is this the same equation that they gave you? Is it the same as this one? No, and it shouldn't be because it should be a completely new equation. So I'm going to go ahead and type in this equation in Desmos and show you what's happening here. Y equals negative x plus 1. What do you notice? That green line is the one that we just made. It goes through the red point, and it's parallel to the original line they gave us. So we're creating a brand new line. Earlier, this is all that we were given. We're given the line, and then we're given a random point. And then they want us to create a line that goes through that red point, which we did, and is parallel to the blue one, which is exactly what we did here. All right, so that's all you do for that one. Now for this, we're going to write an equation that goes through negative 2, 3, but it's perpendicular to y equals 3 minus x. So we're still using the same exact point here, and I'm doing that because I want you guys to see the difference between parallel and perpendicular. So, did I use red over here? I did, so let me use a different color. I'll use lavender. We want perpendicular this time. Okay, so that's our point. We want a perpendicular line, and our equation is y equals 3 minus x, same exact equation. And then we want our final answer in slope-intercept form. Now again, that is y equals mx plus b. Okay, so just like earlier, we want to identify the slope. Now your slope here right now is going to be what? Do we know the slope yet? We do, right? Remember, the slope is going to be negative 1 here. The y is already by itself, so you already know the slope. It's negative 1. So your slope here is negative 1. The question is, do I want to use that same slope for a perpendicular equation? The answer is no. Oh my gosh. The answer is no. Because for a perpendicular line, I want opposite reciprocal. So then you got to think about how negative 1 would be an opposite reciprocal. Well, first, so let me go ahead and write a note. Opposite reciprocal slope here. And actually, I'll move that over here. Okay, right now we have negative 1, and how do we write that as a fraction? Because we're going to have to flip this, negative 1 over 1. So that means our new slope, our perpendicular slope is going to be positive, and then if you flip 1 over 1, it's just 1 over 1, right? If you flip 1 over 1, it's just 1 over 1. So this is just positive 1. So our new slope here is positive 1. So our old slope was negative 1, and now this is going to be positive 1. All right, we have our slope that we need. Do we have our point? Yes, we do. Negative 2 comma positive 3. So our point here is point there. And then we're going to use point slope form again. Y minus y1 equals m times x minus x1. And then we're going to plug in our information. So this is y minus 3 equals our slope of 1. And then x plus 2. So what's the difference so far between the parallel and the perpendicular? Literally the only difference we've done is the slopes part. So for parallel, we use the exact same slope, whereas perpendicular, we use the opposite reciprocal slope. So we don't use the same slope for both scenarios. So you gotta be super careful about that. All right, now we're gonna go ahead and distribute, because we want to simplify this down. So y minus 3 stays the same. 1 times x is just 1x, or just x. And then 1 times 2 is positive 2. And then our next step here is we want to add 5 to both, or not add 5, add 3 to both sides. I was thinking ahead. And then we have y equals x plus 5. And then we're going to go ahead and box our answer. And how do I know this is my final answer? Well, it's in slope-intercept form, and that's exactly what they wanted us to do. So we want to keep it in that form there. Let me go ahead and make that yellow to match our slope-intercept form. All right, now question, is that equation the same as the original equation they gave us? No, and it shouldn't be. It should be a brand new equation. So let's go ahead and type that one in. Now remember that green one was our old one. That was from the last problem. Now they used the exact same equation. They used y equals 3 minus x, and then they used the same exact point. But this time for our equation, we got y equals x plus 5. If I can type the x. Oh my gosh. Hello? There it goes. Notice how it does go through the red point, and it's perpendicular to that blue line. Earlier, our line did not cross at 90 degrees, and this one now does. So notice that there is a difference between parallel and perpendicular. I use the exact same point and the exact same equation for both problems, but when I created a new equation, those equations are completely different. All right, moving on to the next section. This is our second attempt or second try at doing this. So again, same process. I have the exact same point in both scenarios and the exact same equation in both scenarios. So just be aware of that. I'm just showing you that there is a difference. So you don't want to treat them all like they're parallel or perpendicular. Okay. There's obviously one that it will be treated as. So here they want an equation that goes through the point -3, 2, and we want parallel this time. So parallel means I want to use the same slope. And I should probably write that up here. Okay, we want to use the same slope. And then we want it to be parallel to this equation, and then we want our equation that we write in, our new equation, to be in slope-intercept form, so y equals mx plus b. All right, so first thing is first, we got to determine the slope. So if we want a parallel line, we have to have the same slope. The question is, do you know the slope of this equation yet? Answer is no, you do not know the slope of this equation because it's not in slope-intercept form. So the first thing we got to do is we need to subtract x from both sides to get y by itself. So subtract x. -3y equals 7 minus x. And then our next step here is we want to divide everything by -3. Everything. We tend to not divide everything by -3. You guys like divide by two of them and then not the last one for some reason. Well, -3 divided by -3 is just 1. And then 7 divided by -3 is -7/3, not super pretty. And then here's where we mess up. Now, there is a number here. Remember, there's technically a -1 here. So this would be -1 divided by -3. That's going to be positive 1/3. That's a big, big mistake area that we make here. So we got to be super careful here. Negative divided by negative is a positive. Okay. Now, is this in slope-intercept form? Is this in y equals mx plus b? The answer is yes. What's your slope of this equation? It is 1/3. Okay. Now the question becomes, do I use the same slope for this problem, or would I use a perpendicular slope? Okay, so it's a parallel line. If I want to make a parallel line, do I use the same slope or opposite reciprocal? You want to use the same slope. So that means that I want to use the same slope here, which means I would keep it as 1/3. So that's the slope I'm going to use for this problem. Now, how do I know I want to use the same slope? Because I want it to be parallel. And how do I know I want it to be parallel? Because I read the problem and it says parallel. Okay, so that's our slope, and now we need the point. So the point that they wanted to go through is -3, 2. So that's our point here. And we're going to start in point-slope form again. So how much room do I have? Oh, I have plenty of room. Y minus y1 equals m times x minus x1. So it's going to be y minus 2 equals our slope of 1/3. And then x plus 3. Remember, opposite signs in point-slope form. Okay, now we don't want it in point-slope form of our final answer because they wanted slope-intercept form for our final answer, so we're going to have to distribute. Y minus 2 stays the same. 1/3 times x is 1/3 x. 1/3 times 3 is going to be positive 1. Okay, our last step here is we are going to add 2 to both sides to get y by itself completely. So we have y equals 1/3 x plus 3. Is this in slope-intercept form? Yes, it is. Oops, I just realized that that fourth leg was not part of my box from originally. Okay. Question, is that equation the same as the equation that they gave us? And it shouldn't be, right? It should be a completely new equation. So let's check this. We wanted to make a parallel line. So let me go ahead and type those points in. So the point that they gave us was the point -3, 2. And then they gave this equation, x minus 3y equals, what was it? Equals 7. All right. So notice how the red line and the black dot are not touching each other at all. But they want us to make a line that goes through this black point right here, and it's parallel to the red. So hopefully it goes like that. Well, the equation we came up with was y equals 1/3 x. Oops. And then it was plus 3. Yes, it goes through the black point. Black point does go through the blue line, and it's parallel to the red line. So we did this correctly. All right, let's move on to the second half of this, as write an equation that goes through negative 3, 2, and is perpendicular to x minus 3y equals 7 in slope-intercept. So again, identical information, but completely different problem. Okay, so you gotta be super good at reading these through. If you skip the reading part, you're gonna miss it every time. The most common mistake is that you guys treat everything like it's parallel, and it's really bad because 50% of your problems are gonna be parallel and 50 are perpendicular. So you don't wanna treat them all as parallel. Okay, so first we know that we need to write an equation that goes through negative 3, 2. Now this time, again, we want perpendicular. So that's a super important word to know because that's going to tell us what kind of slope we're going to need. Okay? And then they gave us the equation x minus 3y equals 7, and they want our final equation, or final equation in slope-intercept form, which is y equals mx plus b. Now, we already did this in the last problem, but we're going to go ahead and do it again as practice. We do not know the slope of this equation, right? If I want to create a new equation, I got to know what the slope is, what I need to use. But right now, the slope that I need to use is not present because I don't know the slope of this line right now. So just like the last problem, we're going to subtract x on both sides to get y by itself. Negative 3y equals 7 minus x. Those aren't like terms, so you keep them apart. Oops, I just realized that I need to do this in a different color. Pink. Okay, and then our next step here is we're going to divide everything by negative 3. Negative 3 divided by negative 3 is 1. 7 divided by negative 3 is negative 7/3. And then remember, negative 1 divided by negative 3 is going to be positive 1/3 x. Okay, so what is the slope of this equation? Remember, your slope here is always attached to x in slope-intercept form, so your slope here is 1/3. Now the question becomes, do you want to use this same slope for this problem? Well, what kind of equation are we trying to create here? We're trying to create a perpendicular equation. Well, for a perpendicular equation, we want to use opposite reciprocal slope. So we need opposite reciprocal slope. If we want an opposite reciprocal slope, that means our slope is no longer going to be 1/3. We're not going to use the same one. If we want a parallel, we use 1/3, and then we'd end up back at this problem. But we want opposite reciprocal slope for a perpendicular line. So what you want to do is you want to change the sign. Opposite means change the side. Right now, this is a positive 1/3, so now it's going to become a negative 3/1 because you flip the fraction, but that just simplifies to negative 3. So our slope here is negative 3. Okay, so that's the slope we're going to use. And then the point that we want to use, they already gave it to us, is negative 3, 2. Right, yeah. All right, so let's go ahead and, why am I writing so tiny? I don't understand that. Okay. So let's go ahead and put this in point slope form. Y minus y1 equals m times x minus x1. Okay, so we're going to plug in our numbers. So y minus 2 equals our slope of negative 3. Now remember, that slope is different now because we have a perpendicular equation. We don't want to write a parallel equation, plus 3. If we wanted parallel, then it would be 1/3, and then we'd end up back over there. So next step is to distribute because we want to get this to slope-intercept form. So y minus 2 stays the same, negative 3x here, and then negative 3 times positive 3 is going to be negative 9. Our last step is we're going to get y by itself by adding 2 to both sides. So you have y equals negative 3x minus 7. Okay? Oops, everything looks so horrendous over here. Negative 3x minus 7. All right. Now, I know this is my final answer because they wanted my answer in slope-intercept form, and that's exactly what I have here. Now, look at the answers for both problems. Oops, that's probably a horrible color to use. This guy and this guy right here. They're completely different equations from each other. Even though they use the same exact point and the same exact equation inside the given problem, because one's parallel and one's perpendicular, your equations would be completely different from each other. So that's why it's super important that you can tell the difference between a parallel and perpendicular. So let's go ahead and check this in Desmos just to make sure that everything's matching up right. Oops. Okay, so again, we're given the point, negative 3, 2, and then we're given that equation. And they want us to create a new equation that goes through this black point, but it's perpendicular to the red line. And we came up with y equals negative 3x. Was it minus 11? Minus 7. You'll notice that they are perpendicular to each other, and it does go through that black point. All right. So this next section is a little bit different from the previous page. On the previous page, we're given an equation, and then we're given a point, and then we're asked to create a new line based on the previous equation and the point that we're given. Here it's a little bit different, and so my thing is, if it looks a little bit different and they don't give you an equation that's normal, then I want you to go ahead and kind of graph to visualize it. So you're going to see these, and they're going to be a little bit different, and we're actually going to get through them pretty quickly because it's not as math intensive. It's more of just an understanding from understanding perspective. So let's go ahead and look at the first problem. Write an equation parallel to the x-axis, and it goes through 3, -1. All right, so did they give us an equation this time? Did they give us a slope-intercept equation or a standard form equation or anything like that? No, they didn't give us any of that. But we do know that it has to be parallel. We need to create a parallel line, and we want it to be parallel to the x-axis. Now, obviously, it's a lot easier to see the x-axis when we have it kind of drawn out, so that's exactly what we're going to do. So I'm going to go ahead and draw a graph here. Whoops. Draw a graph. I have my y-axis there, and then I'll go ahead and make a x-axis as well. Oh gosh, why is everything, hold on. There we go. Okay, so it's our x and y axis. I'm gonna go ahead and give some tick marks. Now the number of tick marks doesn't really matter. I like to do 5 just for safe measure. So 5 is usually enough for what I need most of the time. I never really need more than 5. Obviously if the numbers are bigger than 5, then you need to make them bigger than 5, but I just have 5 normally. I barely fit 5 on that one. All right, so we want it parallel to the x-axis, and we want it to go through the point 3, -1. So I'm going to go ahead and plot that point, 3, -1. Okay, so 3, -1 is going to be to the right 3, and then down 1, so it's going to be right here. And we want that parallel to the x-axis. So I'm going to highlight my x-axis here. I'm going to highlight that. My x-axis is right here. Now I want to create a line parallel to the x-axis, and it has to go through that blue point. Now remember, parallel means you do not want the lines to cross. And obviously because the x-axis is a horizontal line, then my new line also has to be a horizontal line because we want it to be parallel. So the question becomes, is my line going to look like this? Or is my line going to look like this? And the answer is you want it to look like that green one. You want it to be parallel to the x-axis. So your line's going to actually go through and look like this. Parallel, it's never going to cross that red x-axis. Now, they asked us to write an equation. You have to write an equation here. Do we have an equation written? No, all we did was draw a picture. The picture is just kind of to help us create the equation. You don't really necessarily need the picture for your answer. So you're going to create this equation. Now remember, the equation of a horizontal or vertical line is actually really simple. It's whatever axis it crosses. So this green line crosses the y-axis. So it's going to start off with y equals, and it crosses the y-axis at -1. So your equation for this line is going to be y equals -1. And I'll go ahead and show you what we're doing here. So, oops, Desmos is loading. Okay, so they gave us the point 3, -1, I believe, right? 3, -1. Okay, oops, that's not what I need. All right, so that red point, and it wants to be parallel to the x-axis. Well, I created the equation y equals -1. Notice how it goes through the red point, and this is your x-axis up here, the solid darker line here. That's your x-axis, and this blue line is parallel to it, and it goes through that red point. So this one actually doesn't require a ton of work. It's just more of an understanding. So if you're not given a normal equation, you're not going to do it normally. You're going to draw a picture. Now for the next one, write an equation perpendicular to the x-axis, and it goes through 3, -1. So it's very similar to the last one, so I'll go ahead and draw a graph again. I need to copy and paste these so it doesn't take as long. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 2, 3, 4, 5, 1. Okay, so we want this one to be perpendicular. So perpendicular means we do want the lines to cross, and we want them to cross at a 90-degree angle. Perpendicular to the x-axis, and we want it to go through the point 3, -1. So again, I'm going to plot that same point because that's the exact same point as the last problem, but instead this time I want it perpendicular to the x-axis. Well, remember your x-axis runs horizontally here. If we want it perpendicular, we want it to actually cross the x-axis, and because that's a horizontal line, then we want our new line to be a vertical line. So that new line is going to be this guy right here. Okay, that's perpendicular. Now again, you have to write an equation. Your answer is not the graph. You need to write an equation. So the equation is going to be really simple because it's a vertical line. This vertical line crosses the x-axis, so it's going to start off with x equals, and it crosses the x-axis at +3. Oops. So that's our equation. That's it. So for a problem that doesn't look normal, you're going to have a not normal answer. Oh my gosh, why is my box not drawing? There we go. And I'll go ahead and show you what that looks like here. Now, that blue line was for the previous problem. Now we have x equals 3. And you'll notice it does go through that red point, and it's perpendicular to your x-axis here. All right, so again, based on parallel perpendicular, it's going to change what your answer is going to be. Notice how they use the exact same point in both problems, and they both use the x-axis, but one's parallel, one's perpendicular, and that's why your equations are completely different from each other. Same thing with the last section, right? We use the exact same point in both problems, the same exact equation in both problems, but one was parallel, one was perpendicular, which is why your equations are completely different from each other. All right. Going on to number 4, write an equation parallel to the y-axis and goes through 2, -4. So if you feel like you got the hang of this, go ahead and try it on your own. But if you are wanting to see more practice, obviously, then you can go ahead and just stick around and keep watching the video. But try it on your own, pause the video if you need to, kind of thing. All right, I'm going to copy this because I forgot to do that last time, copy. All right, so I have to spend less time doing that. Okay, so this one we want to make a parallel equation. So create a line that's parallel to the y-axis, and it goes through the point 2, -4. Okay, so let's plot the point first. So we want 2, -4. So +2, -4 is going to be located right here. And we want this to be parallel to the y-axis. Well, let me go ahead and highlight the y-axis. It's super important which axis we're talking about here because it's going to change our equation. So the y-axis runs up and down here. Now we want to create a line that's parallel to the y-axis that goes through that blue point. So our new line has to go through the blue point, but we want it parallel, which means we do not want it to cross the red line, which means our line is going to be a vertical line like this. I'm going to go ahead and, actually, I'll leave it like that. I'll leave it in the background. Okay, now again, you have to create an equation. The answer is not the picture. I get that so often. They'll draw a picture for me. I'm like, that's not what I want you to write an equation. So if I'm writing this equation goes through the x-axis. So this line goes through the x-axis, so it's going to start off with x equals, and it goes through the x-axis at +2. Now, if you're noticing a pattern here, you can go ahead and obviously you don't need to draw a graph. If you got it and you can do this in your head, that's great. But if you're a visual person, you like to see the picture, then I like to draw mine out. All right, write an equation perpendicular to the y-axis and go through 2, -4. Again, this is not a normal problem. And we're like, what do you mean by normal problem? These last 4 are normal problems because you're given a point and then you're given an equation. So these actually require work with equations. So they're giving you an equation with an x and a y in it. So a normal linear equation with an x and a y. If you're not given a normal equation with an x and a y, then you're going to go ahead and draw a picture. So if you don't have a ton of information, you're going to draw a picture. Write an equation perpendicular to the y-axis and go through 2, -4. So again, here we're doing perpendicular, not parallel. So we do want it to cross whatever it's talking about here. Perpendicular to the y-axis, and we want it to go through the point 2, -4. Let's go ahead and plot the 2, -4 point. So it's going to be here. Oops. Okay, and then we're going to highlight the y-axis, so that's going to be here. And we want it perpendicular to that y-axis. We want it to be perpendicular to the red highlighted section. We want it to go through the blue point, which means that that line is going to cross vertically or horizontally like this. So it's a horizontal line. Now, equations of horizontal lines are easy to write. Remember, what axis does it cross? It crosses the y-axis. And what number does it cross on the y-axis? It crosses at the number -4. And I can check this with Desmos, right? So they're giving us the point 2, -4. Okay, that's the point that they're giving us, so that little, that black point right there. And then we're writing the equation y equals -4. Remember, we want it to be perpendicular to the y-axis. This is the y-axis, and then that red line is perpendicular to it. It crosses at 90 degrees. All right, moving on to the next section. Now, this next section is a little bit different, but again, it's not a normal equation. And what I mean by not normal, you're not given an x and a y in your equation. And that's when you draw a picture. Write an equation parallel to x equals 4 and goes through -1, 2. Okay, so let's go ahead and highlight some important information here. So we want it parallel. Parallel lines means we want same slope, or we don't want the lines to cross each other. And we want it parallel to x equals 4. So they're giving us an equation this time, but it's not a normal equation. We want it to go through the point -1, 2. Again, if it's not a normal equation, if there's no x and a y, you graph it. That is the easiest way to do these problems. These problems are super easy to miss because people overthink them way too much. Okay, so let's go ahead and plot our point. The point is -1, 2. That's going to be located right here. Now we want it parallel to x equals 4. So we're not parallel to x or y axis here. We're going to parallel to x equals 4. So we need to graph this equation. So how would we graph x equals 4? Well, that's going to be on the x-axis at +4. And notice how the tick marks go up and down. This line is going to go vertically up and down. Okay, so we have a vertical line here. Okay, so x equals 4 is graphed right there. We want a parallel line to that red line. So we want it to go through the blue point and be parallel to the red. So the question is, should I have a vertical line that goes up and down, or should I have a horizontal line that goes side to side? Remember, parallel means you do not want it to cross. So we're wanting it to be a vertical here. Sorry, there's people cleaning outside my classroom. That's why that was a loud bang. That scared me, honestly. Okay, so, oh my gosh, okay. So again, we want to write an equation, so please do not give me a picture for your answer. That is not what I want. Okay, equation for the green line. That's the new line that we made. So let's go ahead and graph that, or give an equation. Remember, how do we write the equations for horizontal and vertical lines? Super easy. You look at the axis that it crosses. The green line crosses the x-axis, so it's going to be x equals, and then it crosses the x-axis at -1. So your equation here is x equals -1. So let's go ahead and plot this so I can kind of show you what we just did. They gave us the equation x equals 4. So that was our original equation that they gave us. And then they gave us a point -1, -2, I think is what they gave us. Right? Is that right? Yeah. Okay, so they gave us the line, and then they gave us that green point, and then they said create a line that's parallel to the blue one, and we said x equals -1. Notice how this new line right here that we just made goes through the green point and is parallel to that blue one. So that's exactly what we just did. Write an equation perpendicular to x equals 4 and goes through -1, +2. Okay, so perpendicular means we do want it to cross. We do want opposite reciprocal slopes, whatever kind of problem it is. And then we want it perpendicular to x equals 4. And then we want it to go through the point -1, 2. Okay, so let's go ahead and plot that. So -1, +2 is going to be located right here. And we want it perpendicular to x equals 4. Again, to graph x equals 4, you go to the x-axis, and it's going to be +4 because it's a +4 there. And then it's going to be a vertical line. And we want a line perpendicular to that red line, but we want it to go through that blue point. Perpendicular means I do want it to cross at 90 degrees, so that line is actually going to go horizontally. Notice how it's perpendicular to the red one. Okay, so remember, we want to write the equation. You're not done until you write an equation. The equation of this light purple line is going to be y equals, because it crosses the y-axis, and it crosses the y-axis at +2. Okay, and I can prove that again. Remember, the blue line is the original line that we're given. The green point is what they want us to use, and we've created the line y equals 2. And notice how it is perpendicular to the blue one. Okay, it's perpendicular to the blue one, and it goes through that green point. All right, moving. Oops, I just realized I did this in the wrong color. All right. Next one, write an equation parallel to x equals, or parallel to y equals -3 and goes through 4, 2. Okay, so let's go ahead and highlight our information. We want it parallel to, whoops, y equals -3, so we have a different equation here, and then we want it to go through the point 4, 2. So go ahead and paste a graph here. I'm actually going to shrink it a little bit. Copy. All right, we're going to shrink it so that it fits on the page. We're going to plot that point. So 4, 2 is going to be +4, right 2, so, right 4 up 2, I'm sorry. +4 up 2. +4? Right 4 up 2. There we go, +4, +2. I'm going crazy. It's been a long day. It's 6:12 up here if you couldn't see. So we are going to go ahead and graph the equation that we're given. So it says we want it parallel to y equals -3. So we've got to graph that so we know where that is. Y equals -3. This is not a normal equation, which is why I would like you to graph it, because it's a lot easier to see. y equals -3. Well, that's going to be located on the y-axis at -3. And on the y-axis, our tick marks go side to side. So this is going to be a horizontal line. Let me draw that line a little bit better. There we go. It is a horizontal line, and we want it to be parallel to that red line. So we're creating a new equation that goes through the blue point and is parallel to the red line, which means we do not want them to cross. If we don't want the lines to cross because they're parallel, then this line is going to go side to side as well. It's going to be horizontal too. Oops, that's not what I meant to do. I need to move this blue point up. There we go. Okay, so notice how those two lines are parallel to each other. They do not cross, and it goes through our blue point. So our equation here, we're going to write an equation because that's what they want us to do, not draw a picture, but the picture is helpful. The equation is going to start off with y equals because it goes through the y-axis, and it goes through the y-axis at +2. All right, moving on to the next one, write an equation perpendicular to y equals -3 and goes through 4, 2. Okay, so we'll go ahead and plot that graph on there again. And we're going to highlight our information. So this one wants to be perpendicular. And we want it perpendicular to y equals -3. And we want it to go through the point 4, 2. So let's plot that point 4, 2. And then we're going to plot the original equation, which is y equals -3. That's going to be on the y-axis at -3. And that's going to be a horizontal line there. Now we want it perpendicular, which means we do want them to cross at a 90-degree angle, and we want it to go through that blue point, which means this line is going to be a vertical line. Now, how do you write the equation of this line? Well, this purple line goes through the x-axis, so it's going to be x equals, and it goes through the x-axis at +4. So it's x equals 4. And I did the equation in the wrong color again. Whoops, whoops, whoops. All right. So again, this section is actually a lot less time consuming than these four because all you have to do is kind of draw a picture because you're not given like a normal x and y linear equation. All right, moving on to our very last problem in the notes. Write 2 equations, one parallel and one perpendicular to the graph shown below. It has to go through the point -3, 1, and we want it in standard form. So there's a lot of stuff happening here. So the first thing we want to note is we want an equation that's parallel. So we want a parallel equation. And we want a perpendicular equation. So they want us to create 2 equations. So we're going to have to do 2 problems here pretty much. And we're going to want it to go through the point -3, 1. And we want it in standard form. What is standard form? Remember, standard form is ax plus by equals c. And remember, there's 3 rules to standard form. Rule 1. X and y on the left. Rule 2, a must be positive. And rule 3, no fractions or decimals. All right, so those are the 3 rules for standard form. All right, so let's go ahead and do parallel first. We're going to do parallel first. Actually, we'll find the information first, but I'll do parallel on this side. And then we'll do perpendicular on the other side. Okay, so we're going to create 2 equations here, one parallel, one perpendicular. Now, obviously, they did not give us an equation, but they did give us a line. Now, if I plotted the point -3, 1, that point is going to be located right here, -3, +1. You'll notice that it's not located anywhere near this line, and it's not supposed to, because they want us to create a brand new line that is either parallel and also perpendicular to the line that's already shown here. So the point 3, -1 is not going to be on the line. It's going to be over here somewhere. All right, the first thing we got to do is we got to remind ourselves what this means. We want to create a parallel line to the line that's already given. Remember, parallel lines have the same slope. Same slopes. Okay, so let's go ahead and first identify the slope of this line because we have to know the slope in order to create a parallel or a perpendicular line. So first thing I'm going to do is find the slope. I'm going to start here at the bottom and I'm going to go to the top here. So remember, the easiest way to find the slope of a line is to do rise over 1 if you're given a graph. Rise over 1 is the easiest way. So our rise here is going to be 1, 2, 3. Now, again, I'm starting at this bottom point. So 1, 2, 3. Our rise is up 3, so it's going to be +3. And then our run is going to be 1, 2, 3, 4. Well, our run is to the left 4, so that's -4, which means we have -3/4. That's the slope of this equation. Now, I don't really care about anything else. I don't need to write the equation of the line because the only thing I care about at this line is the slope. The slope here is -3/4, okay? Well, if that's the slope and I want to make a parallel line to this equation, the question is, do I use the same slope or do I do opposite reciprocal slopes? I'm going to use the same slope. So I'm going to use the exact same slope that we're given, which means I'm going to use the slope of -3/4. Now, in order to write an equation of a line, I need a point and I need a slope. Do they give us a point to use? And the answer is yes. They gave us a point -3, +1. Well, -3, +1 is going to be our point. Not -3, +1. Was it 1 or was it 4? Oh, it is 1. Okay. That's our slope. That's our point. Now we're going to start in point-slope form. You have to start in point-slope form because that's all that you really have here is your point and your slope. So you have to start in this form. Okay, so let's go ahead and plug in our information. So y -1, your y value here is -1 because it's opposite signs, equals -3/4. And then x plus 3. Okay. Now, again, our final answer, we want it in standard form, not point-slope form, so we have to keep going here. All right, so that means we're going to have to distribute and kind of get rid of our parentheses. So y -1 is going to stay the same. -3/4 times x is -3/4 x. And then -3/4 times 3 is going to be -9/4. So not super pretty, I know, but, you know, it is what it is, and we got to deal with it. So, all right, the next step is we want to go ahead and get the y by itself. So we're going to add 1 to both sides. Y equals -3/4 x minus 5/4. Now, is this our final answer? No, because they want it in standard form. This is in slope-intercept form, so you have to know the difference between your forms here. We don't want it in slope-intercept form, we want it in standard. Well, the first rule of standard is x and y need to be on the left. So I'm going to move that x to the left side. Because it's negative, I'm going to add 3/4 x to both sides to move it to the left. So it's going to be +3/4 x. You always want to write your x value first. Now that y is positive, so you're going to have plus y equals -5/4. That is a negative sign there. All right. Go ahead and move these up. Oh my goodness. What is going on? Why is it not? There it is. Okay. Is this in standard form? And again, the answer is also no, because in order for it to be in standard form, a must be positive, x and y on the left, and no fractions or decimals. So x and y are on the left, a is positive because a right now is 3/4, but you can't have any fractions. So we're going to multiply this. We've got to multiply everything by a number to get rid of the fraction. And remember, to get rid of a fraction, you multiply by your least common multiple of the denominators. Since your denominators are both 4s here, you're going to multiply everything by 4. Not -4 because you don't want to change any signs. Everything gets multiplied by 4. And usually what happens is you skip the y. You don't want to skip the y. Y is also important. You want to distribute to that as well. Just because it doesn't have a fraction doesn't mean it doesn't get treated equally. 4 times 3/4 is going to be 3. So we have 3x. 4 times y is 4y. And then 4 times -5/4 is going to be -5. Oops. I forgot the equal sign. Okay. Now, is this in standard form? Yes, because x and y are on the left. You have no fractions or decimals. And you have no, what's it called? A is positive. So that's the parallel line to this equation. So if I were to graph this orange, yellow equation, whatever color you see, it would be parallel to the one that's already graphed, and it would go through that blue point. All right, let's do a perpendicular equation. Now we're using the exact same graph to do this one. Now for perpendicular lines, we want opposite reciprocal slopes. Okay, so the slope that we're given right now is -3/4. So the question becomes, do I use this same slope to create this equation, or do I do the opposite reciprocal here? And because it's perpendicular, you have to do opposite reciprocal. So if it's parallel, you use the same. If it's opposite reciprocal, you do the opposite sign and you flip the fraction. So that means that we have a new slope. So our perpendicular slope, I'm going to put the little symbol there, perpendicular. Okay, opposite sign. So because it was negative, now it's become positive, and it's going to be positive 4/3. Okay, and then the point that we're going to use is the exact same point that we used earlier, which is -3, 1. They want us to use that exact same point, except that this time we're not doing a parallel line, we're doing a perpendicular line, which is why our slope is different. And you'll notice when we finish our equation that the equations are not alike at all because they're two completely different lines. Okay, so starting in point slope form. So y minus y1 equals m times x minus x1. So we fill in our information, y minus 1 equals 4/3, positive 4/3. Oops. And then x plus 3. Okay, now from here, we want to distribute because we want to get rid of the parentheses because we're trying to get to standard form here. So I'm going to leave y minus 1 as is, and then we're going to distribute 4/3 times x, which is going to be 4/3, oops, x. And then 4/3 times 3 is going to be positive 4. That worked out nicely. Okay, and then next thing we're going to do is we want to get that 1 to the other side because, again, we want to get to slope intercept before we get to standard form. So I'm going to add 1 to both sides. So we have y equals 4/3 x plus 5. Well, from here, this is in slope intercept, we got to get to standard form. So the next thing I'm going to do is I got to get x and y on the left. So that x needs to go to the left. Because it's positive, I'm going to subtract it to move it to the other side because you always have to do the opposite when you're balancing stuff. And if you want it to go away, you have to do the opposite. Now remember, you want to write their x term first. So this is going to be negative 4/3 x, and that y is positive. So plus y equals positive 5. From here, you want to make sure that it's in standard form. X and y are on the left, but a is not positive, it's actually negative, and you have a fraction here. So we're going to have to multiply everything by a number to get rid of all of our problems. Well, first of all, a is negative. In order to get rid of a negative, you multiply by a negative to get rid of the negative. So we're going to have to multiply a negative here. And then to get rid of our fractions, the only denominator here is 3, so I'm going to multiply by 3. So the negative takes care of the negative a problem. So I'll go ahead and highlight that so we can see that. Trying to figure out what color to highlight in because I've already used so many of them. We'll do this one. The negative gets rid of that negative sign, and then that 3 is because we want to get rid of the fraction. So negative 3 times negative 4/3 is going to give me positive 4x. Negative 3 times y is going to be negative 3y. Negative 3 times 5 is going to be negative 15. Now this equation is in standard form. X and y are on the left. You have no fractions or decimals, and your a value is positive here. So notice how these two equations are completely different from each other. These two are completely different. What was the only difference between them? One, you use the same slope. The other one, you use the opposite reciprocal. We use the exact same point for both, but the slopes are completely different, which is going to change your answer completely. So always pay attention to what you're being asked for. And again, you're going to have to go the long way if you're given a point and a slope. Here, in these 8 problems, you're not given a point or a slope. You're just given a point and then a line to reference to. So that's when you would draw a picture. So again, if you're given something normal like an x and y, you're given an equation and a slope, you want to use that and use your equation and use point slope form. But if it doesn't look normal and you see x-axis or y-axis, or you see like x equals 3 or y equals 3, like a not a normal looking equation, then the best way is to draw a picture. So that is it for parallel and perpendicular. I know it was a lot and it is a lengthy set of notes, but if you have any questions, just please let me know.